And let's see what sets are. Most of this content on sets is from your high school books. So I'm just going to rush through it. You will get the slides. You also have the lectures. Should make sure that you know all of this stuff. Okay. अगर इसमें कुछ problem है तो we have a problem. Okay, we have an issue. We won't be able to move forward. So we know a set is a collection of objects. Elements are the objects in the set. उस set के अंदर जो objects होते हैं उसको हम elements कहते हैं. Remember, there are two things that are very important in the definition of set, which are probably not written here. The first thing is the elements in a set are always unordered. Okay, there is no order between the. If I give you a set which has 1, 2, 3, so 1, 2, 3 is का जो order है that's irrelevant in the set. I can write set as 2, 1, 3 or 3, 1, 2 or 3, 2, 1. Excuse me. Right? So the order of elements in the set does not matter. And the second important property of set is that the numbers in the elements in the set are unique. You can't have, you can't have two copies of the same element. So if I write 1, 1, 2, then this thing is not a set. It's a sequence or whatever you want to call it. It's a multi-set, but it's not a set. Okay? Every element in a set is unique. And the second part is there is no order between elements of the set. These two things are very important when defining a set. Remember it. This is a notation we write braces, these curly braces for the set. We write that X is in set. This is the in symbol when X is an element in the set. We cross this symbol to write that X is not a member of the set. Okay? So it's, for example, a set which has an element 2, an element monkey, and an element strawberry. Okay. Empty set is a special set which does not contain any elements. We call it null set as well. This set in here is not empty. Okay, this set contains one element which is an empty set. A singleton is a set which only contains one element. इस तरह के हम set को singleton कहते हैं. So for example, ये वाला जो set था ना, which contains the empty set, is a singleton. Okay, because it contains one element. Finite sets are sets which contain finite number of elements, जिसकी कोई cardinality है. Infinite sets are sets which does not have a cardinality as such. Okay, they do have cardinality, but we won't talk about it. Cardinality of a finite set is denoted by this thing A, उसके दोनों साइडों में बार लगाए हैं जैसे normally mod में हम लगाते हैं. Is the number of elements in A. Okay, it counts the number of elements in A, and we call it the cardinality of the finite set A. We won't talk about cardinality of infinite sets. Okay, although it's defined, and it's a very interesting topic to find the cardinality of infinite sets, but we won't talk about it because we are interested in discrete sets. Sets key properties. If P is a property, then we say that we can denote a set as this, that X is a variable and P is a property which holds true for all the elements in X. Okay, so for example, if X is the set of odd integers, which is 1, 3, 5, 7, 9, so on, then I can write this set as X bar. X is equal to 2k plus 1, where k is an integer. Okay, that's the definition of an odd integer. We use Venn diagrams to denote sets in their intersections and unions. So you should be able to do this on your own. A subset is a set. A is a subset of B whenever every element of A is also an element of B. Okay. So in particular, we have that N is a subset of Z, is a subset of Q, is a subset of R. Okay. So non-negative integers is a subset of all integers, is a subset of rational numbers, which is a subset of real numbers. Okay. This is quite easy. A set is also a subset of itself. Always, an empty set is also a subset of itself. So we have the statement. Try answering the statement. So it says that let A be a set which is 2k plus 1 for some k, for every k in Z, and B is a set which contains 4k plus 3 for k in Z. Is A a subset of B or not? What do you guys think? So A is a set which has integers of this form 2k plus 7, and B has elements of the form 4k plus 3. Is A a subset of B or not? Anyone?
Yes.
It is?
Yes.
You must have
Yeah.
seen the answer. The answer is no.
No, sir.
Why? Why not?
Sir, but what if is zero?
सर हम उसको 4k+3 को in terms of 2k+7 नहीं लिख सकते तो I don't think
No, no,
वो
no, no. So if the statement is wrong, you have to come up with a counter example. Okay, give me an example. Give me an element which is in A and it's not in B.
Sir, 9 is in A, but it is not in B.
9 is in A and it's not in B. So when K is 1, I get 9. And uh,
Sir, are we
when
assuming that K is an integer?
yeah, K is integer, K is integer, K is in Z, so K must be an integer. So when K is
Then
1, in B I get 4 plus 3 is 7. When K is 2, I get 4. 8 plus 3 is 11. You're perfectly fine. Yeah, 9 is a number which is in A and it's not in B, which means that the set A is not a subset of B. You're right. What's your name?
Adia.
Okay. All right. So proper sets. We say that a set is a proper subset of B whenever they are not equal. Okay, so if A is a subset of B and it's not equal to B, we'll say that A is a proper subset, and that's how we denote a proper subset. Equality is a really important function in sets. We say that two sets are equal if uh, if they have the same set of elements. Okay, order does not matter. Right, for example, over here ABC is the same set as CBA. AABC is the same set as ABC. Okay, we can also say that set A is equal to set B if and only if we have these two statements. That's actually the one way to prove that two sets are equal. Okay, अगर आपने शो करना हो कि दो सेट्स हैं और वो इक्वल है और फिर उसके अंदर एलिमेंट्स इस तरह नहीं पड़े हुए ए बी सी की तरह ना, यहाँ पे तो बहुत इजीली आप बता सकते हैं कि ये वाला एलिमेंट दोनों में है, ये वाला एलिमेंट भी दोनों में है, ये वाला एलिमेंट भी दोनों में है, राइट? So the nice way to prove this equality between two sets is that you prove two statements. You prove that A is a subset of B and you prove that B is a subset of A. Okay? अगर ये दोनों statements आप prove कर दें तो then you are done. It proves that A is equal to B. All right? This is usually how we prove that two sets are equal. Okay, so here's a practice example. A is a set which is 2k plus 5 and B is a set which is 2k plus 3, and we need to show that A and B are the same set. Okay, um, so I mean they are infinite sets, right? I can't element wise compare them. I can't say that every element in A is also an element in B, right? So all I can do is I can show that A is a subset of B and I can show that B is a subset of A. अगर ये दोनों statements मैं show कर दूँ तो I'll prove that A is equal to B. So over here I prove that A is a subset of B. You start with an element, arbitrary element x in A. Okay, I can write x as 2k plus 5 like this. Okay, which means that I can write it as 2k plus 2 plus 3. Okay, 5 can be written as 2 plus 3, which means that I can write it as 2k plus 1 plus 3. K plus 1 is integer. If k is an integer, then k plus 1 must be integer as well. Okay, which means that x is in B because that was the definition of B. B was 2k plus 3 for some integer k, and that's why we are done. Similarly, is side के ऊपर instead of adding, you define it as by subtracting. Okay, plus करके उसको subtract करेंगे तो you'll get the same statement. Right? So that's an example of showing that two sets are equal. We show that A is a subset of B, and then we show that B is a subset of A. I'm skipping this, and this is exercise for you which does not go in now because the solution is right here and you have seen it. Set of sets. In your set, जो elements हैं, those elements can also be sets. जैसे हमने for example एक set देखा था which contained empty set. Okay, so you can have a set of sets as well. So for example, A is a set which contains 1, 2 as a set, and it contains 1 as an element, it contains 2 as an element, and it contains 1, 2, 3 as a set. Okay, so it's possible that a set contains diverse type of elements. एक तो वो numbers है और एक set of numbers है. Okay, normally set of sets को हम family कहते हैं. Instead of saying that set of sets is a set of sets, we say that A is a family of sets. Okay? Similarly, subfamily की type भी use होती है. All right, power set is a set of all subsets. For example, if you have 3 elements, green circle, red square, and blue triangle, then all of those sets are subsets are here. You have empty set, you have singletons, okay? You have sets of 2 elements, and the set which contains everything. A power set is set of all these elements. Okay, set of all subsets is called the power set. And if your set contains 10 elements, what would be the size of the power set? What would be the cardinality of the power set? Anyone?
Could you repeat the question?
Yeah, the question is, if your set contains 10 elements, what's the number of elements in your power set?
55.
Whoa, how did you come up with 55? How?
Combination for
Sir, it's the progression wala formula. 10 plus 9 plus 8 plus 7 plus.
Whoa, what's 9? Where does 9 come from? Where does 9 come from? What is 9?
9 comes from the fact that there are 9 subsets of size 2 within that set.
Whoa, hold on a second. Why are there 9 subsets of size 2?
So because there can be 9 combinations.
Wow. How many subsets of 2 do we have here? We have 3 elements. How many subsets of size 2 do we have here?
3.
We have 3, right? So that's wrong, right? Why should you expect 9 subsets of size 2?
2 power 10.
Yeah, it's 2 power 10,
इस तरह नहीं
right?
होगा 10C1 plus 10C2 plus 10C3 combinations अगर हम use करें.
Yeah. It starts with 0, 10 choose 0, 10 choose 1, 10 choose 2, 10 choose 3, up till you reach 10 choose 10, and this is equal to 2 raised to power 10. Beth, इसको exercise में add करें to find the cardinality of power set of a set with n elements, where n is a fixed number, and also try proving that 2 raised to power n is equal to nc0, nc1, nc2 का sum. Okay, these two are part of one question.
Okay.
All right. Set of sets or family of sets की हमने बात की. We know that the cardinality of power set is 2 raised to power n. These two statements, are they true or false? There is an arbitrary set x, उसके power set का size 17 है. There is an arbitrary set, उसके power set का size 0 है. Are these two statements true or false? Or true, false,
First
false,
one is
true?
false.
What? बोलो.
First one is false because 17 is nothing, no 2 की power something.
Yeah, 17 is not a power of 2.
Yep.
What about second one?
False.
True है second
No.
one.
False,
Yeah,
false.
second one is also false, right? 2 raised to power n is not equal to 0 for any value n. Okay, for any integer n, I mean when n is 0 you get 1. Okay, you can't have a negative number as a cardinality of a set, right? So both of these statements are not true. Intersection of two sets is the elements which are contained in both of them. So for example, over here we have two sets A and B, and their intersection is E and F. Okay, you guys should have seen it in your high school. Union of sets are elements which are in either of the sets. Okay, दोनों sets में जो कुछ है वो सारा कुछ मिला दें तो you will get a union of set. But the things which appear in the intersection can't be repeated. Okay, E and F will appear only once in the union, right? Because we know that no elements can be duplicate in this in a set. Set difference or the elements, so it's not commutative. Okay, it's not order matters here. A minus B is not equal to B minus A. A minus B are the elements which are in A but not in B. Okay, similarly B minus A are the elements which are in B and they are not in A. Symmetric difference are the elements which are not in the intersection. Okay, intersection से बाहर जो चीजें हैं उसको हम symmetric difference कहते हैं. Okay, they are either in X, either in A or B, but not in both of them. That's the symmetric difference. You should go through it. Complement of a set is everything that's not in the set. Okay, you start with the universe. You assume there is some universe, and then you take a set A. The complement of A is everything which is not in A. So when you want to show that A is equal to B, you need to show two things. A is a subset of B, and you need to show that B is a subset of A. When you need to show that X is intersection of A and B, you need to show that X is in A and X is in B. Okay, these two statements. I'm just sort of, you see, over here we are actually doing the case by case analysis. Okay, so these are proofs by cases, and they become easy when you divide them in these cases. So if you have to prove that X is in A union B, you need to show that X is in A, or you need to show that X is in B. Okay, दोनों में से कोई एक statement आपने show करनी है. When you need to show that A intersection B is empty, you need to show that you need to when you need to show that A intersection B is empty, you need to show that there is no element which is in the intersection of A and B, right? When you need to show that A intersection B is not empty, you need to show that there exists an element which is in A and it's also in B. Okay, so this is sort of simplification of these proof statements. Counting sets is something there that we stop at. We will see this later on Thursday. We'll start from here on Thursday.